We're going to start talking about magnets this week. We'll be talking about them for the next couple of weeks. And we're going to start off today by reading this book, Magnets Push, Magnets Pull. I'm going to jump around through the book and give you some demonstrations as we go. A world without magnets would be a world without computers, printers, cell phones, televisions, vacuum cleaners, and microwave ovens. It's a magnet's invisible pulling and pushing force called magnetism that helps power all these devices. So we've been talking, a few weeks ago, we were talking about motion and pushing and pull, so this ties right into that. Magnets are attracted to anything iron, steel, nickel, or cobalt, and some less plentiful metals, including niobium and samarium. There are two kinds of magnets, simple magnets and electromagnets. You're probably most familiar with the simple magnets, the kind found in toys and that are used to hold papers to refrigerator doors. So simple magnets such as this that you might have on your refrigerator. Toss some US coins. Does your magnet stick to any of them? So you might be thinking to yourself, maybe you're thinking, maybe it sticks to the silver coins because those look like metal, but maybe not so much to the penny. So let's take a look. I'm going to tilt this down, and I have my coins here and my little magnet, and I'm going to check. And I can see that it's not attracted to any of those. None of them are magnetic. That would be a property, just like we talked about properties way at the beginning of the year, where we can talk about color or hardness or texture. We can also talk about whether an item is magnetic or non-magnetic. But if we put a magnet on the hood of our car, we may find that it sticks. That's because most cars are made from steel. Also, if you took a few cans from your pantry or your cabinets and checked those cans, you might find that the magnet does stick to some. Some are made of steel, but other cans are made of aluminum, and magnets are not attracted to aluminum. So another little test you could do. Simple magnets come in many shapes and sizes. If you have a magnet of any size, you can use it to test the force of magnetism. So our kits that we got through that fundraiser at the beginning of the year, we had tons of different kinds of magnets, magnets that looked like this. We had bar magnets that were shaped like that. We had the U magnets, all different kinds, our magnetic wands. So they come in all different kinds of shapes. So I want to show you another demonstration. I'm going to tilt this down like that. Move my things out of the way. I'm going to put some paper clips here. Most of us know that paper clips are magnetic and are attracted to magnets. So I'm going to put those magnets right there, and I'm just going to take my magnet and I'm just going to start moving it closer to, and I can feel my magnet pulling to my paper clips, and I can see that the paper clips are getting attracted to the metal or to the other paper clips, as is right there, right? They start sliding in and sticking to each other. The magnet's invisible pulling force is pulling those paper clips across the table. Okay, so now I have a bowl here, and it has a little bit of water, and I've put in it a few paper clips, and we're just going to see if our magnet is strong enough to work through through the glass. So I'm just going to kind of come down. I don't know how well you can see that, but I'm going to come down and see if I can actually get those. I don't know if you saw that. Let me do it again. So the magnet is working through, oops, doesn't want to let go, through the water. So again, I'm going to stick that in. If you just watch that magnet, and then it sucks those paper clips right up. So it can work through the water, but also, down there, it can work through the side of the glass. So I don't know if you can see that paper clip. I can pull it right up the side of the dish. So I can move it, see me moving them around in the bowl, and then I can pull it right up the side of the bowl and take it right out of the bowl. It's very powerful. Also, and we saw this before, a lot of you did this at school. If I have just a sheet of paper, let me tilt this a little bit. I have just a sheet of paper with a paper clip on it, right? My paper clip is strong enough to move, my magnet is strong enough to move my paper clip around that paper, right? And a lot of you were experimenting back when we would have those fun Fridays, and you found that you could even attract something that was on top of your hand with a magnet underneath your hand or underneath the table. So they're pretty strong. Let's see, what else do I want to show you? Here's another example. I'm going to put my bar magnet, so bar magnet just means it's shaped like a bar. I'm going to put it underneath my paper. And I'm going to take some of these iron filings. They come in a little tube. I just want to open it carefully so I don't spill any. And I'm going to just sprinkle them around the edge of my magnet, just like that. Okay, so we know that these iron filings are magnetic, and this is to show more of the magnetic field, okay? So I'm going to tap on this paper, and as these metal filings move around, we're going to start to see them creating a pattern. See how those are kind of spreading out? Those metal filings are trying to be attracted to that magnet. The pattern shows where the magnetic force is the strongest. It's the strongest by the two ends where many of the filings should have gathered. So let's keep going. I'm going to just kind of shake those in. Here's our magnet right here. You might see the outline of it. So as I shake this, do you see how they're getting attracted to that magnet? I might even shift my paper over so I can get closer. Oop, the filings are holding it. So as I keep shaking this paper, those filings are getting sucked right into the magnet, and we can see how they're creating these little lines. You can see that very well. They're creating these little lines where the filings are joining together to get closer to the magnet. You see how that's happening? So that's kind of cool. So that's called the magnetic field. We'll be talking about that a little bit more later on. So the two ends of a magnet are called its poles. Each magnet has two poles, a north pole and a south pole. So let me show you. Here's a bar magnet. Oftentimes they are labeled, sometimes they are not. Here's a U magnet, and this one is labeled as well. You can see on the ends, north and south, right? You can test your bar magnet to see which is its north pole and which is its south pole. So if you weren't sure, such as in this magnet that isn't labeled, and you wanted to know which was the north and which was the south, there's a little experiment that you can do. I'm not going to read about it now because it's not something we need to worry about, but that you can figure out which is the north and which is the south. Okay? So if you look at any globe, the most northern part of the globe is called the North Pole. We know that. And the southern part is labeled the South Pole. The poles of every magnet always point north and south because the Earth is a huge magnet with a relatively weak magnetic field. Its magnetic pull is strongest at its two ends, its north and south poles. So that's just a little bit of information and how that ties into our north and south pole of the magnet. Now, This is something that we experimented with our magnets on those fun Friday days. I'm just trying to get my magnets away from those filings. So the North and the South are attracted to each other. So if you've ever heard that saying, opposites attract, the North and the South of two magnets are going to attract. As opposed to when you put two norths together, two edges that are both the north ends, if you put both of those together, they repel each other or push away from each other. So let me show you. Here's my magnets. Okay, so you can see I don't even have to hold it. Those are, that force, I can feel it sucking it right in, right? Opposites. But if I put two norths together, no matter how I try, there's a force there that's pushing it away, and I can push them together, but it's not going to stay. See how it kicks it up? It kicks it right up and away because it's opposing it. It's not attracted to it. Okay. Let's see. What else do we want to know about these? That's basically all I want to talk about for today. We're going to be doing some reading and some, hopefully a little bit of experimenting. It may be my showing you an experiment and then discussing it from there. But I want you to be curious about magnets. If you have some magnets around the house, play with them. There'll be some different alternative activities that you can do with magnets that might be fun and continue our exploring and our curiosity about magnets. That's all for today. Take care. Bye.